talk about, let me leave this first sequence up here. Even this one, if it's an easier sequence, but if I asked you what is A3000, you're going to go, I don't want to do that. I don't want to add 3 that many times. But there's got to be, I'm just adding 3. There's got to be a quicker way to do it. Okay, so let me do this. What's A1 from this sequence? 1. What's A2? And how did I get to 4? I added 3. So I took 1 and I added 1, 3. So how do I get to A3? And of course that's how I got 4. How do I get to A3? I start at 1 and I add how many 3s? 2. So I take 2 steps, right? So I'll take 1 and I'll add 2 3s. And that's how I get 7. Do you guys see that? So what am I doing now? I'm not trying to make the sequence harder. I'm trying to capture what the real pattern is so I can write an equation. So then if I want to figure out what A3000 is, I can just plug 3000 into my equation instead of freaking write this thing 3,000 times. How we doing? You're good? So then A4, of course, would be 1 plus 3 3s. Does that work? What's 3 times 3? Plus 1? 10, right? Is everybody cool so far? Do you guys see what's happening? This is not a huge step from what we just said. I just keep adding 3s. So why did I choose to write it this way? Because now I can see what the real mathematical pattern is. For A1, how many 3s did I have to add? None, because I'm already there. Right? And then for A2, I added 1 3. For A3, I added 2 3s. So let me see if you guys understand? So what's this number related to the one I want?
Because
1 less. Because to get to the first one, did I have to take any steps? No, I start at 1. Then I take 1 step to get to the second. I take 2 steps to get to the third. All right, let me let that sink in. Yes?
So does that mean that if you want to multiply by 29, you got to multiply by 28?
Oh, yeah. You multiply, exactly. 1 less than the one you want. So if I wanted A29, I would actually put a 28 here, right? Because I will take 28 steps to get to the 29th number. Okay. I don't want to make too big of a deal out of that. So let me see if you guys can take this next step. This is the real math step. This is computation shit. Here's math. What's AN? Now think about what we just said. If it's A2, what's here? 2 minus 1. A3? 3 minus 1. A4? 4 minus 1.
So you just replace it by n.
So AN? So that captures the pattern, that captures the idea. Now I know it doesn't look as simple as you wanted it to, but it still is relatively simple, to be honest. You start here and you go this many steps. Start here, go this many steps. So one reason I like to do this also is, well, number one, is a great application of pure math.
But why is it negative?
Where are we looking? Here?
Yeah.
Because if it's 3, this has got to be 3 minus 1. If it's 4, this has got to be 4 minus 1. So if it's n, this has got to be n minus 1.
Okay.
So real quick, this is A1, 2, 3, 4, 5, 6. What's A7 going to be? Just 19. So let's check the formula out. A7 would be 1 plus 7 minus 1 times 3. Is that cool?
Yeah.
And what is 1 plus 6 times 3? 1 plus 18 is 19. The correct answer, of course. Right? So we have our first official formula. Let's generalize it, make it an official formula. So the formula now that you'll be able to write on a formula sheet for the test. What was 1? Why did I put a 1 here? What's the big importance about 1? Is it always 1? Where'd that come from? First term.
Yeah.
So this is A1 plus n minus 1. Now what's this 3 all about?
That's the variable.
And let me see if I can tease the word out of you. That's how far apart. So that is the distance. So I'm going to use the letter D for that. D for distance. And it's actually D for difference, but that's the same thing. What's the difference? 3. So I'm going to put that right there. So let's do a different sequence and use the same formula. What's got to be true about the sequence I choose? It has to be based on multiplication or what? Addition. It's got to be based on addition to use this formula. Does that make sense? Oh, I love the look I'm getting from some guys. You're like, no, but continue. So let's see. What about this? Let's try another one. So let's start somewhere different. Let's say 7. What you got, Jeff? 13, 19, 25, 31. So let's identify a few things. First off, is this arithmetic? Is it based on addition?
Yes.
Yeah, because I keep adding what? 6. So what is that? What's 6? What letter does that get for my formula? What is 6? 6 is the common difference. That's D. Cool? So I'm really pleased, dear God. Please come with me. So many guys are like, man, you took something so simple and you made freaking algebra shit out of it. What I hope you do instead of that is go, okay, the formula's going to look worse because it has to have room for whatever this thing looks like. If I put a 7 here or 28 or negative 417, it's got to have a place for it. Do you see what I mean? The formula's got to be more general. But now I just got to go, well, what's the formula you need? It needs to know this. Well, I know this. It needs to know this. What's A1? 7. So now, take a minute and just write what the formula is. What's AN then for this sequence? Write it. Don't say it. Alright, so you just got to plug and chug, right? What's A1? 7. Plus n minus 1. See, that's n because I didn't say which one I want yet. So it's got to be the general variable n times 6. So now if I ask you, okay, what's A 27? Take a minute and figure that out. What's the 27th term in that sequence? Instead of just continuing, I could just quickly do this. Math helps me get to the answer quicker. What? So n is what? Just make sure everybody sees this. What's n going to be?
27.
Yeah, 20. Well, n is going to be 27. And then here it's 27 minus 1 is 26. I like it. But I always get somebody who's like, doesn't know where I got the value of n from. Well, it's got to tell you. It's got to replace n with something. That's what you replace n with. Times 6. So what's 26 times 6?
13.
156. And 7 plus 156? 163. So if you did keep going with this pattern, oh my God, you would eventually get to that answer. So thank God for math coming in and saying, dude, don't do that shit. Let's get to the answer. Cool.
I have a question for 65. Oh, it's for the homework tonight. I had it.
Oh yeah, let's hold off on that for until next time. I want to do one more thing with this, and then we'll call it a day. This one is exceptionally cool. Let me see if you guys can get this. This is an urban legend in math. You ready? There's no death or anything. I'm not going to make a movie out of this. Gauss. I don't know if anybody's ever heard of Gauss before. He was famous for Math Geeks again. Gauss did a lot of shit. Holy crap. That's how we measure the strength of a magnetic field, is in Gauss. So Gauss, supposedly when Gauss, this dude, was in elementary school, the kids were all going crazy, and the teacher's like, I want to read my newspaper. You kids, you add the numbers 1 through 100, and then, and when you're done, we'll do something. So he started reading his paper. And Gauss was a little smart ass. He's like, all right, I'll come up with a quick way. So Gauss added the numbers up from 1 to 100. he added them up in like 10 seconds. So he didn't do 1 plus 2 is 3 plus 3 is 6 plus 4 is 10. Holy shit, that takes forever. He figured out a much faster way to add these up. And it works for any arithmetic sequence. Why is this an arithmetic sequence? Because it's 1 plus 1 plus another 1 plus another 1. You guys understand? Mm-hmm. So like the even numbers would be an arithmetic sequence because they keep adding 2, so forth. So here's what he did. What is 1 plus 100? 101. What's 2 plus 99? 101. Oh, shit. 3 plus 98. 101. 4 plus 97. 101. So how many 101s will I have?
100.
No. What did it take to make 101? It took 2 of these.
Yeah,
50 of them. So it's 100 numbers divided by 2 because I'm going to pair them up. Is that cool? I'm showing you why the formula is the way it is. But hopefully you understand this. This formula is so beautiful because it's just semi-easy. And then where's the 101 come from? Or the simplest place it comes from is from A1 plus AN. Well, I should put the extra. So it's 100 divided by 2 times 1 plus 100. Let me stop there for a second. Do you guys understand the basic idea here? I'm going to have 101 plus 101 plus 101, but how many of them I'm going to have? I'm going to have 50 of them. So I'll just do 50 times 101. Yes, sir?
For the first one you wrote, but instead of the 100, would that be AN? Right there. For the formula, the first formula?
Yeah, this would, the general formula would be N. Sorry.
Okay.
Right, how far you want to go?
Okay.
The number of numbers divided by 2. So you see how many pairs you've got? And then times the first term plus the last term to get what that repeated sum is going to be. So here, this number is kind of interesting. It's not something you would expect. The first 100 natural numbers add up to be 50-50. That in itself is kind of nifty to know. 1 plus 2 plus 3 up to 100 is 50-50. I like it. Cool. So this is the formula for the sum of n numbers from an arithmetic sequence. So this is our second formula. This is how you figure out in a specific sequence element, like the 27th number in the sequence is 163. This is how you figure out the sum of the first however many numbers in the sequence. And it's a relatively easy formula. You gotta love that shit. Sounds like it should have been a lot worse than it really is.
So in a sense, the N is like the same for the arithmetic one right here you just told. Is the N the same as AN?
No, definitely not. So right here, what do I got? 1, 2, 3, 4, 5, 6. So what is 37? What's the symbol for 37?
That would be AN.
Well, A6 in this case, right? Specifically, is that cool? Stay with me now. It's the last thing we're going to do. So if I wanted this sequence, and I want to know what the sum of the first 6 numbers is. Right? Well, before we even do the formula, what is it? Let's just add them together. 20, 39, 64, 95, 132. Does that sound about right? Well, let's see if I'm right. So I predict that S6 will be 132, if I added those right in my head. Let's see what the formula says. Right? What's N going to be? 6. N is 6. I want the first 6 terms. So N is 6 divided by 2. What's A1?
Starting point is 7.
7.
Yeah.
And what's AN? What's the last term?
So
37. Because I only want to go 6 out. Right? So it's the 6th term, really. So this will be 3 times 44. Which is 132, right? Because you got to carry the 1 from the 3 times 4.
Oh, okay, I see what you mean.
132. So if you add them up, you do get the same answer. Now, whenever I do an example like that, people are like, well, why the hell do you do this shit? Just add them up. Because what if I want to know what S600 is? I don't want to do that shit, right? I'd rather just plug something in and get the answer, right? So if it's a simple pattern, math can, and actually if it's a more complicated pattern, math can still capture it and give us a shortcut. All right, that's plenty. So we got about halfway through 1.7. We got to still talk about geometric sequences. Cool. So I'll have the quiz graded tomorrow, and we'll see what happens.